All right. In chapter 12.1, we learned about counting, and we learned that the basic definition for probability is the number of ways of doing something you're interested in divided by the total number of ways you're doing things. And so, certainly important to be able to count things properly. In section 12.2, we're going to learn some more advanced counting techniques, and we're going to learn about three different types of things, how many different ways there are of arranging things, how many different permutations are possible, and how many different combinations are possible. So my guess is the permutations and combinations words might be a little bit weird to you, but we'll figure out what they are. So, first off is just how many different arrangements are there for the letters in the name Rocky? So imagine like a Scrabble tile, and you have those 5 letters, and you're putting them in order, right? You could do R-O-C-K-Y, which is the best way to put them, or you could do them in alphabetical order. Well, that's not alphabetical order. I think this is alphabetical order. And you could do this sort of thing. So anyway, there's 4 different combinations there. I don't know, there's a whole lot of other arrangements that are possible too, but I'm not sure I'm going to want to list them all. That sounds like a nightmare. Let's try a tree diagram. So how many different letters could go first? Well, there's 5 different letters that could go first. And then once we've chosen a letter to go first, then there's 4 different letters left that could go afterward, right? And then for each one of these, there are 3 letters left that could come. And even though I can't really draw all this all out very accurately, I'm starting to sense that there are 5 different letters that can go first, and 4 letters that could go second, and 3 letters that could go third, and 2 letters that can go fourth, and then there'd be 1 letter left over. And the counting principle said that we can just multiply that all together, right? 5 times 4 times 3 times 2 times 1, that would be 120. And so there's 120 different ways that you can arrange the letters in the word Rocky. And that arrangement that multiplication of 5 times 4 times 3 times 2 times 1 is so popular in probability and counting principles that it has a name. And a symbol. It's called a factorial. And so if you ever see a number with an exclamation point directly behind it, it's indicating that exact thing, where you start with that number and you multiply all the way down. So we say 5 factorial, and what's meant is 5 times 4 times 3 times 2 times 1, which is 120. And so 8 factorial would mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's a lot bigger. By the way, 0 factorial doesn't exactly make sense, like starting with 0 and multiplying down until you get 1. But people who get paid a lot of money to do probability calculations decided that 0 factorial makes sense to have that equal 1. So just it is. That's the rule. 0 factorial is 1 because it makes the math make more sense that way. Anyway. So that's what an arrangement is. The next idea that we need is a permutation. And so a permutation is kind of like an arrangement. It's just that you're not allowed to use all of the letters. So in this question, how many different arrangements are there for the letters in the name Rocky if you're only allowed to use 2 of them? So like you could do R and O, or you could do O and R, or you could do C and K, or K and C. You could do Y and R and Y and O, right? Or O and Y, or R and Y. So there's not as many, I don't think, this time. But there still are quite a few. And we can still use the counting principle to help us. So how many letters can go in that first choice? Well, we could choose any one of the 5 to go there. And once we've chosen 1 letter, then in that second place, we wouldn't be able to use that letter again. And so there are 4 letters left, and 5 times 4 would be 20. So this idea is also really popular in these sorts of questions. They call it a permutation. And so a permutation is some arrangement of objects when you have a limited number of them and you're only allowed to choose some of them or select some of them at a time. It also has a variety of different ways that can be symboled. So that last problem where we had 5 different things and we were picking 2 of them and putting them in order, that could be written like this. So out of 5 things, pick 2 of them and put them in order. I've also seen it written like this, 5P2. I've even seen it abbreviated like this, 5NPR2. So those are all different symbols that mean the same idea. And there's a formula for that. If we wanted to find it, we could calculate that this is 5 factorial. And then this is 5 minus 2, or 3 factorial. So if you did 5 factorial divided by 3 factorial, that's 5 times 4 times 3 times 2 times 1, divided by 3 times 2 times 1. That would be, well, these guys cancel out, and you're left with 5 times 4 is 20. So anyway, it's a formula for permutations, kind of a fun little guy, but we'll also use some technology, some calculators to calculate these things. One other concept that we need is combinations. So how many different combinations are there of letters in the name Rocky if you're only allowed to use 2 of them? Now, this sounds a lot like the last question we have, but there is a significant difference. In the last question, we not only had to pick 2 letters to use, but then we also had to put them in some order. Combinations, we're not going to put them in order. So we're going to consider, for instance, OR or RO. We're going to consider that the same combination, and we're not going to count it twice. We're just going to count it once. And so CK or KC, those both count as the same combination, and so forth. Because of this, there's going to be less combinations than there were arrangements of 2 letters in the name Rocky. So the combinations idea is also a super popular one. It also has a symbol and a formula, and so it uses C instead of P, and so that question would be C5-2. I've seen it written like this, 5C2. I've seen it written 5NCR2. I've even seen it written like this, because combinations are so popular. So out of 5, how many ways are there to choose 2 of them? So sometimes this C is pronounced choose, by the way. So out of 5, choose 2, if you hear me say that. Anyway, first examples. These calculations are so important. We need to be able to calculate them easily. And so 8 factorial, remember that means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so one way you could do that is just like this. Get out a calculator and type it in. However, if you're going to get out a calculator, you should realize that factorials, permutations, combinations, they all have ways to type them in. So if you have a graphing calculator, let's start there. So if you got one of these, graphing calculator, you can find all of these commands in the math menu. And so you would press the math button, which on my calculator is in the left-hand side, about right in the middle, basically. And in the math menu, there's a probability section that you'd want to choose. And look, here's your factorial, and here is your permutations, and here's your combinations. So depending on which model calculator you have, they might look a little bit different, but mine says 8 P3. It does that calculation for us. Or 8 factorial up here. That's 4,320. So we can write that in, 4,320. If you are using, on the other hand, the Desmos calculator, then the Desmos calculator also has the ability to type these things in. You'd want to find them in the extra functions that are off to the side. And so here's your factorial, here's your permutations, and your combinations. And when you type those in, 8 factorial is pretty standard, but the combinations or the permutations, you'll have to push the button first, so NPR first, and then choose how many, and out of that, how many you're picking. So there's also a comma, which is when you're typing the numbers in, the comma's right next to the numbers there. So anyhow, this option down here that says for choose 2, or choosing out of 4, 2 items, that is apparently the number 6. And 12, pick 5 and put them in order, or the permutations, 12, 5. That is 95,040. And a lot of times these don't come isolated, but they're combined with other calculations as well. So, for instance, if I have this is out of 5, choose 2, and this is out of 9, choose 3, and we need to find each of these numbers separately and then multiply them together. So I'm going to use my calculator for that in a moment. I'll go to the math menu and over to probability, and I'm going to choose NCR and put my 5 in and my 2 in, and that is 10. And then I'll do the same calculation with 9 and 3. So 9 NCR 3 is 84. And then finally I'll multiply these together. So 10 times 84 is 840. Now, the rest of this video is going to be different problems that we can solve with these sorts of calculations. And probably the biggest thing is going to just be trying to figure out what of these different things are we talking about. Do we have an arrangement or a permutations or combinations or whatever? So first example, or second example, I guess. We have a tennis coach. He's got 10 players on his team, and he needs to arrange a lineup and pick 6 players to play and put them in order. So 1 singles, 2 singles, 3 singles, and all that sort of stuff down. So different orders definitely matter, right? If you got placed in first singles versus 6 singles, that would be a very different experience for you, wouldn't it? So this sort of thing can be done instantly in a calculation. It's a permutations problem. And so if you recognize that, you could say that this is out of 10. We're picking 6 of them and putting them in order. And so you can calculate 10 P6 using a calculator. Another option that you could do, if you didn't realize that it was a permutations problem, is you could say, well, how many different players can play first? There's 10. How many players can play second? 9. How many players can play third? 8. And 7 would be available to place next, and then 6, and then 5. And so you could kind of work out a lineup that way. And then you could take all these and multiply them together and get your answer that way. And the cool thing about math and these probability calculations is they both would work and give you the same answer. So I'm doing the 10 times 9 times 8 times 7 times 6 times 5 calculation, and it gives me 151,200. So it's the next question. There are 20 horses in the Kentucky Derby. How many different finishes are there for first, second, third, and fourth? So this is a permutations problem. So if you wanted to, you could say 20 P4, and get your answer. Or you could find it by saying, well, there's 20 horses that could place first, and 19 that could place second, and 18 that could place third, and 17 that could place fourth. So last time I did a multiplication answer, so this time I'm going to do 20 and go into the math menu and choose NPR and then 4. So 20 NPR 4 is 116,280. Wow, that's a lot. All right, we've got 5 women and 4 men, and we need to sit them together in 9 different chairs. And we want to know how many different arrangements are possible. So arrangements makes me think, I'm putting things in order. And the first question is, what if there are no restrictions on seating? Which means I've just got 9 total people, and I can put them in whatever order I want. Well, that would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or 9 factorial. So, math menu, go to probability, choose factorial. That's 362,880. The second question is, what if the men have to sit together and the women have to sit together? So that would mean that there are 5 or 4 spaces for men and then 5 spaces for women. So in that situation, there are 4 men that could go here, 3 that could go here, 2 that could go here, and 1 that could go there. And there are 5 women that could go here, 4 women that could go here, 3, 2, and 1. And I could multiply this all together. That would be one big combination. Technically one big arrangement. Or I could do this part of it is 4 factorial. And this part of it is 5 factorial. And I could do 4 factorial times 5 factorial. And get that answer. So 4 factorial is 24. 5 factorial is 120. So 24 times 120 is 2,880. All right, a couple more examples. Number 5 here. How many different 5-card poker hands are there if you play with a standard 52-card deck? So if you have 52 cards and you're dealt 5 of them, how many different hands are possible? Now, in this particular problem, usually the order of your 5 cards doesn't really matter. I mean, there's a couple games where it might, but most of the time you're allowed to move the cards around, and it doesn't matter what order they're given to you in. And so this would be a situation where it's a combinations question. So for combinations questions, you can't really do the how many different cards could go here, that sort of thing, because that's when you put things in order. Since you're not putting them in order, that strategy doesn't really work. Instead, this is one where you really need to use that sort of formula. So out of 52 things, we're going to choose 5 of them. So that could also be written as a combinations of 52, 5. Either way, I'm going to use a calculator for this one. So I'm going to go to the math menu and find my NCR option on my calculator and put 52 before it and 5 afterward. And whoa, that's a huge number. 2,500,000, I can't even say it. 259,890. So 2,598,960. That's why even if you've played poker like a bunch of times, you probably have never gotten the exact same hand twice, because there are so many different possibilities. All right, let's see. We have a restaurant. They have 16 waiters and waitresses, and every night a team of 9 has to be assigned. So, how many different teams are possible? Assuming that it doesn't matter what order people are assigned, this is just a combinations question. Out of 16 waiters and waitresses, we need to choose 9 of them. So 16, choose 9. And again, good candidate for a calculator. 16, choose 9 is 11440, 11,440. Now, things can get more complicated if you need to pick certain number of guys and girls, or if the first person picked is like the manager and the last person picked is the busboy or something, then it becomes more like a permutations problem. But they didn't mention any of those details in this, so let's not overcomplicate it. So, example 7. Yeah, here's a more complicated example for you. We've got a committee of 5, and we need to choose some mathematicians, and we have 5 different mathematicians and 6 different economists, and we need to choose 5 of them to be on our team. And if all we had to do was just pick 5 people out of all of those, there are 11 total people, right? 5 and 6. And so that's a total of 11. And we need to pick 5. So that would be if there were no restrictions. However, they said that we need to have 2 mathematicians and 3 economists. So we're going to choose our 2 mathematicians from this list. So out of 5 mathematicians, we're going to choose 2 of them. And then out of our 6 economists, we're going to choose 3 of them. And so for each choice of mathematicians, we can have any one of the choices of economists. And so in situations like that, that's where the counting principle would apply, and we would multiply these options together. So let's see what 5 choose 2 is, and 6 choose 3, and then we'll multiply those together. So 5 choose 2 is 10. I should have known that. We saw that number earlier today, didn't we? And then 6 choose 3. 6 NCR 3 is 20. And if we multiply 10 times 20, we have 200. All right. For our final examples, we're going to be looking at some card sorts of problems. So we have a standard deck of cards here. There are 4 suits, clubs, spades, hearts, and diamonds. And then there are 13 ranks, aces, 2s, 3s, 4s, 5s, and so forth, up to the jacks, queens, and kings. Those are called ranks. And we're going to see how many different combinations of cards there are. We're going to go with picking 5 cards out. And the first idea here is how many different ways are there for me to have a flush. A flush is when you have all 5 of the same suit. So let's say how many different ways are there for me to have, say, 5 different clubs. So if I want a hand that is 5 different clubs, well, there are 13 clubs available, and I want to know how many different ways are there for me to choose 5 of those. So that would be 13, choose 5. And so out of 13, I'll go to the math menu and choose 5. I got 1,287. Now, that is not quite the right answer. That's how many different ways there are for me to choose 5 clubs. However, there are 4 different suits. So I could also have chosen 5 spades or 5 hearts or 5 diamonds. And so there are 4 different suits available. And so I need to take this answer and multiply it by 4. And that would be 5,148 total hands. Another question is, how many different ways are there for me to have a hand that has 3 queens in it and 2 kings in it? So when I look at the queens, there are 4 queens available, and I want to know how many different ways are there for me to choose 3 out of those. So that's out of 4 queens, choose 3 of them. And then to fill out the rest of my hand, there are 4 kings available, but I have to pick 2 of them. And so that is 4, choose 2. And I will take those 2 results and multiply them together. So 4, choose 3 is 4, and 4, choose 2 is 6. And so there are 4 ways of choosing the queens and 6 ways of choosing the kings. If I multiply those together, that's 24. All right, last question says, how many different ways are there for me to choose a hand that has 3 hearts, exactly 3 hearts, so no more, no less. That means the other cards have to be spades or clubs or diamonds. So let's start with looking at the hearts. There are 13 hearts available, and I need to choose 3 of them. So 13 math, going over the choose, and 3. There are 286 different ways for me to have 3 hearts. But that's not a complete hand. So if I just choose 3 cards, if out of my 5, I still have 2 left over. So I can choose those 2 cards from the remaining cards. So there are 13 plus 13 plus 13. There's 39 other cards available that I can choose my remaining 2 cards from. And so I'm going to multiply this option by, out of 39, choose the other 2. And so that's probably a bit bigger of a number. Let's see what that is. 39, choose 2 is 741. And so if I multiply these together, I get 211,926. So 211,926. So anyway, there's some thoughts about arrangements, permutations, combinations, and some of the different types of calculations you can make with it. If you have any troubles, by all means, let me know. And I hope you have a wonderful day. See ya.